Welcome everyone at the last webinar during this online week. And we're back with another live demonstration by Instrument Solutions together with Specs Catenax in Canada. In the right corner, you can already see Jeroen van Bokstel. He will start with the presentation and then we will change to Nadia Duchamp from Specs for the live demonstration. And as usual, you can ask all of your questions in the chat box on the right. Well, go ahead, Jeroen, and good luck.
Okay, thank you, Aline, for the introduction. On behalf of Instrument Solutions and Specs Catenax, welcome to this webinar. First, I will briefly introduce the companies, followed by the basics and the advantages of the fusion technique in general, followed by the advantages of the Catenax electric fusion systems. Then we will switch over to a live demonstration from Quebec City in Canada, performed by Nadia Duchamp of Catenax. At the end of the demo, there will be time for questions and discussions, but during my presentation and during the live demo, you can already put your questions into the chat box. Instrument Solutions is a privately owned Dutch laboratory supplier. We supply equipment and supplies for three main fields of activity, which are elemental analysis, chromatography, and material characterization. We have partnerships with international manufacturers, so we are the distributor, but we also provide local support. Local technical support. Instrument Solutions and Specs Catenax are exclusive partners since 2014 for the Benelux area. Catenax is a Specs sample prep company, and Specs itself is again part of Cole-Parmer. Catenax was founded in 2002. It's a pioneer in the electric fusion technique. It's the first company that designed a fusion system run on electricity. Specs is, or Catenax is located in Canada and the UK, where they are part of Specs Sample Prep. And of course, Specs has also locations in the United States. The fusion process, to be able to do fusion digestion, you have to have a completely oxidated sample to have an effective process, but also to protect the platinum. So if your sample is completely oxidized, you can run immediately fusion. But if it's partly unoxidized, or you suspect it's partly unoxidized, you first have to do an oxidation. This can be done in the muffle furnace, but because we can control the temperature with an electric system very well, we can also do this in the Catenax systems. Then we will do the oxidation of the sample at a temperature below the melting point of the flux. When the sample is oxidized, we will move the temperature to the melting point of the flux. Then the sample starts dissolving. We help the dissolving by rocking the crucible. When the sample is completely dissolved, we can cast the molten flux with the dissolved sample into a platinum mold. The result is then a glass bead that can be analyzed in an XRF system. The other option is to pour the mold or the melt into stirred beakers with dilute acid. It might sound a little bit strange to pour 1000-degree melt into a room temperature beaker with acid, but as long as the melt does not contain more than 3 grams of flux, you can pour this, and the cooling capacity of the 100 ml acid is good enough to do this without any problems. Advantages of the fusion for XRF sample prep. Of course, XRF is a technique that implicates a lot of matrix effects. The glass beads are homogeneous down to the atomic level. so you have a very homogenic sample to analyze. Matrix effects are highly reduced, partly because of the diluting of the sample. The reproducibility of the line intensities are greatly enhanced, and calibration standards can easily be made of virtually any composition by mixing pure oxides with flux and then fusing this into beads. Then you can make very good standards. You can also use fusion to make solutions. This is mostly done for ICP techniques and for radiochemistry, for example, for alpha spectrometry, but you can also use it for atomic spectroscopy, of course, or atomic absorption. Advantages are that it's a complete digestion of a sample, which is not often not the case when using concentrated acids. It's very efficient in digesting complex materials that are digested difficultly by acids. It's very safe, can be used as an alternative for HF digestion. And it's also very fast. Complete digestion takes approximately 20 minutes, but sometimes it's even shorter. And this is from the start to a cooled bead or a cooled solution. We're going to focus on the X-fluxes of Catanax. This is the X600, which is the fixed 6-position system. This was the first of the X-fluxes that was designed. It's the newest generation with a lot of unique features. Some of them are that there are no metal parts exposed in the furnace, so no contamination can occur from the parts of the system. The heating elements are located in the back wall of the system, and these heating elements are impervious to flux, so they can be destroyed by the flux. It has a very unique feature called dynamic power profile control. You can control the intensity of the heating elements separately to have an exact same temperature at all positions in all the crucibles. And down below on the right, you see the solutions module. It's a very easy to clean area, and it can be, you don't have to change if you, for example, do both XRF and ICP. You don't have to change the solutions module. You just have to put in the holders of the mold. The X300 is uses the same technology than the X600, but it's a system with a modular setup. It has 1, 2, or 3 positions, and once you have, for example, a 1-position system installed, you can later on add a 2nd or a 3rd position. So again, the unique features of Catanax, the heating elements are impervious to flux. They are using a very unique heating element for this. There's no exposed metal in the furnace. It has a full shield protection, which is not always the case, especially not when you're using gas heated systems. The dynamic power profile control, it takes care of uniformity of the temperature in the entire furnace, and it keeps running even if one of the elements breaks down. These specific heating elements have a very long lifetime, but they have an ending lifetime. So if one breaks down, the others compensate during the run. And also you can keep using your system until there's time to replace the heating element. Catanax offers excellent support. They offer lifetime free method development for Catanax users, but they even offer method support for any type of fusion users. So now for the real fun part of this webinar, we're going to switch to Canada, Quebec City, where Nadia Ducharme will perform a live demonstration. So now I would like to give the word to Nadia Ducharme.
Thank you. Hi, everyone. Today we're going to see how the X300 fluxer works. So this is a beast. What we're going to start by is weigh the flux, because I have an automatic dosing machine that's going to do it for me. So here let's say we want to do a 32 millimeters bead. So we want 7 grams. We set 7 grams. Add the container. You can work in a ratio mode or with the whole weight like I did. What you can do in a ratio, he weights a small portion of the flux, then you add your sample and he add another portion of flux on top. So it's almost a little blended before you have to mix it yourself. So this can simplify your needs if you have a lot of samples to do at the same time. So you put one, you blend it, you put it in the machine, and while you do that, the flux spencer can weight another one for you. So I'm going to take a standard cement sample. What I'm going to do is take approximately 1/10 of the flux I used, pretty standard ratio. You can always adjust how aggressive you want it to work. Me, I just didn't want it to overshoot, so we might have to wait some time. You can play with the tolerance you want to have to. So it's going to stop very soon. So now it's done. Gonna tear the balance. Weight 0.7 grams of sample. So that's it. So I'm mixing a little the two. Usually try to not scratch too much the bottom of the crucible. So here you go. So now we're gonna do today both solution and fuse bead. So here you have a unlock system for the door, because everything is closed. If you have an accident or something, nothing's gonna spill over you. So I have a button that I can show you later to push the crucible holders on the back. So then I can put my Teflon beaker, and there's a stirrer module at the bottom, so it's stirring my solution at the same time. I'll make my crucible coming back, and then I have my crucible solution, and here the crucible with 7 grams of flux to do my 32 millimeter bead. And then you close the door. And I'm gonna show you how the software works to start a fusion. Okay, so here's the button I pushed to put the crucible holders at the back so you can access to the solution module. And then here you have the lock button for the door if you want to open it or close it. Usually it's always locked on when you have a fusion. So when the LED light is red, it's hot. So for you to not burn yourself, it's gonna lock itself down until it cools down totally and the lights are blue, and then you're good to go. So you have 6 steps to choose from. So like Irun mentioned earlier, if you want to do an oxidation step, You can play with the ramping of temperature. So you choose to go at 600 degrees or 1050. We like 1050 because it's not too hot, so the flux or samples will evaporate and everything's gonna melt down well. The time here, this is the shaking. We're gonna see further. Here I have a pretty standard method, so it's very short. I have nothing at the first step. So here's the speed. If you want to do ramping, this is fast, but you have 10 degrees per minute, 15 degrees. You can play with that. This one is locked down because it's a preloaded method that comes with the instrument. So I have my first step is the, okay, usually you take maybe some minutes at the 4. You like to take a step, no shaking, with 1, 2, 3 minutes for the flux to melt down very well. And once everything is melt, now you're gonna put some motion in it. So here at the 5th step, we like to see two minutes because this sample is very, very straightforward, fully oxidized, and very simple. So 2 minutes of rocking at a 25 degrees angle of back and forth at a speed of 100. And the last step is a more angle, a 30-degree angle, but at a 5% speed. So what it's gonna do is that the last step, we're gonna really mix your sample and the flux together. And then at the last step, we're gonna slowly rock to degas all the sample and flux you have. So if you have some leftovers, bubbles at the bottom, they're gonna release at that step. After that, you have a pouring mode. If you have a solution, you can push that button further, so it's gonna go green. Me, I won't do that today because I want to do my bead, so I want the step of cooling to be all there. If you do not want to pour, you can also push the button off, so the melt will cool down directly in the crucible. At Catanax, we like to use 2 steps of cooling. So the first step is a 1 minute room temperature for the bead to slowly cooling and to avoid crystallization. And then you have a 5 minutes of forced cooling with fans that's gonna go on. And then after, everything's gonna be room temperature. So after the 6 minutes of cooling, everything's gonna be good. You can put your hand on the bead, no problem. So what I'm gonna do now is start the fusion. So when I'm gonna push the start, the crucible will go in the furnace. So I will change my cameras for you to look at this. So I'm gonna unlock the door and push start. So the door of the furnace opens, the crucible enters in the furnace, door closed, and after you can follow the fusion steps going straight here. Oh, I forgot to show you. Oops. So here the lights change color. So when it's red, it means you have a fusion in, or when it's out, it means that's up. So usually the door will be closed at this step. So I close the door to not have the red block up there. So here you can follow the steps of the fusion. So the first step, you have your 1 minute 30 at 1050 for the flux to melt down. Here it's not gonna start that step until the furnace has reached back its full temperature at 1050. So now, since the furnace opened the door, it lost a little bit of temperature. So that's why it's gonna go ramping a little bit until it goes back to 1050, and then the countdown will start. So now we have 12 minutes approximately to wait until it's fully done, but it's approximately 5 minutes until we can see the pull. So when it's gonna come out, you're gonna see the pouring live in action. Here you go. So like Jeroen said, we offer free method development service. So if you are a client that wishes to learn about Fusion, if you already do Fusion or not, you can send us some samples. If you want some report, we can work on it. And then if you like what you see, you can decide whether you want to buy or not, or if you want to go into Fusion. So the poll is not finished yet. The standard application we have, it's always fully oxidized samples, but we do can some work with metallic samples, but you have to add a oxidation type at the beginning. So it's either with solid oxidizers or heating. You can do pre-treatment in the furnace. So if you want to do like a preheating of your sample, you can put the sample in the crucible, put it in the furnace for the time you want at 1000 or less. You can do that directly in the furnace. Also, if you want to do ashing with, let's say, petroleum products, you can do that in the furnace as well. Just have to watch for a good ventilation for anywhere, any organic matter if you have in your sample.
Nadia?
Fusion, yeah.
Yeah, we have some results from the poll.
Okay.
And 42% worked with geological mining cement. And we have...
we have metals alloys as well.
Yeah, you see it. Okay, great. It's quite equal. Yeah.
So it's pretty standard metals. They are like in, not metals, or fully oxidized samples, like in university research or something like that maybe. Fusion is excellent for those type of sample, but it's also very well for refractory samples and some types of silicate materials. That's why fusion is an ideal technique for radiochemistry, because boraate fusion is efficient in digesting silicate materials and other complex mineral structures. So that's why it's excellent to do solution with fusion, so you can avoid strong acids or even HF, which is a good thing to get away from. And PGMs also, you can do solution with sodium peroxide in the furnace with no problem. You can set the temperature more lower than 1050. The instrument can handle it. It's made for, if you want to do it like a 400, 500 degrees, no problem. You can do your fusion in that. We also had an application in private laboratories. So any type of cement, ores, minerals, everything environmental. In metal and alloys mining, it's more like base and precious metals. We do have ferroalloys too, but these, depending on the type, might need a complex oxidation types. How many minutes I have? I have 50 seconds before the pouring occurs. I don't want to miss it. That's why I'm looking at it. What do I have? Ceramics, catalyst. We have manufacturers also. Everything that's do raw materials, QC, and things like that. They like to do fusion, because fusion always have better qualities than pressed pellet for those. And that's pretty much all. We have a lot of application coming here. So if you think you have maybe something that's could work with fusion and you want to know, no problem. You can take contact with us, send us your sample, and we'll work on the method development for you and send you a report. So now we have maybe 1 minute left. Okay, so what I did today, I took a position for solution at the right, because sometimes with universities, with students and things like that, we do recommend having like a one dedicated place for solution, because students don't have to play with the mold fingers to take off and take in. So you have less risk of breaking things. So with that, we can have a pouring of the fuse beads on the left and a pouring of solution on the right. we do have an ICP OES. So solution usually with 2.5 grams of flux and 0.2 grams of sample is more than enough for me. If I need more, I can put more sample in it, because you have to take into account the limit of solubility of lithium borate flux in a solution. Because 3 grams of flux in 100 millimeters of solution is pretty much the max you should go, because you will have undissolved particles if you go higher than that. Okay. Here you go. So now it's gonna start 1 minute of temperature room cooling for the fuse bead. So the bead will slowly become clear, and the instrument will beep as long as my door is not closed, because it knows that I have risk of burns if it opens. And the solution usually it's shorter than that, because when the fusion melt goes into the solution, it goes until like maybe 60 degrees Celsius, not more than that. So within 3 minutes, you could take off the beaker without problems. It might be a little hot, but you can handle it. So after that, you can pull that on a stirring plate, waiting for it to dissolve completely, and then transfer into the container you want it after, if you want to adjust the volume. So now the bead cleared a little more. The 1 minute is done. So the fans are starting, and you have a 5 minutes of cooling down. So what I'm gonna do now, I'm gonna close the door for it to beep no more. Okay. So the lights are still red because it's still hot, but at the end of the 4 minutes, it's gonna go blue again. So it means it's safe to the touch. So here I have my mold fingers. I took off, and it's really easy to put them back on. But if you are only doing fuse beads, the mold finger will be adjusted for your size, and you won't have to touch them again. So Jeroen, if you have something else to say now would be the time.
And that's okay. Thank you for your excellent presentation of this this system. While we wait for the cooling, yeah, maybe you can tell something about the recently added feature of like remotely controlling the system.
Yeah, sure. Now if you want to service, or if you have a limb system, if you want to track, for example, your samples with code or numbers, you can either plug the instrument on Ethernet. So Cadax here, the Cadax service can log into your instrument and tell you what the problem is. And with the limb system, you can have all the samples you scan, because you can put a scanning instrument on it, so you can track the samples you do and put them in your computer for it to track your samples.
Okay, I also understood that it's convenient for people doing, for example, alpha spectrometry, that they can, because they often deal with radioactive samples, that they can control this feature so they control the system from a distance.
You can see the screen from a distance, yeah. If you have like an office outside of the laboratory, and you have like I don't know, a 20-minute fusion, and you have a lot of sample to process, you don't want to miss time between your fusion, so you can go to your office and see the whole screen, the whole HMI on your computer, so you know when the fusion is done or at what step you are. So if you know the fusion is done in like 2 minutes, you can go back in the laboratory and be set and to put the other samples in.
Okay, we have some questions of customers. So one is from Simon. He says, can you compare and quantify the typical accuracy and precision of fused beads versus pellets and analyzed with the same analysis method?
Usually it's more reproducible, and yeah, it's more reproducible, but it's not, the numbers won't change, but you will have less problem of like mineralogical problem and things like that. So it won't be the same. You could have a good press pellet calibration, but it depends on the sample you have, because if you have multiple I don't know, like iron material, it could be worth it to analyze it on a fuse bead, because you will have it completely and it would be better. And with the fuse bead, the advantage of doing calibration is that you can do a in-house calibration with pure oxides, so you can mix them depending on your need, what you cannot do with press pellets because of the mineralogical effect. So now you see it's blue again, so it means it's coming at room temperature, so it will be safe to touch.
Okay. Well, another question is maybe you can explain a little bit what is really the advantage for doing solutions with this system. For example, for alpha spectrometry or ICP?
The advantage?
Mm-hmm.
For ICP, it means that you can go in trace elements, whether in XRF you cannot. So if you have like it depends maybe on the system of XRF you have, because we have a benchtop XRF, so there are some elements when it's in too low proportion in the samples we cannot see. So I have to go to the ICP, and the ICP will be better for the low trace elements, and will be it's very reproducible. It's very good for those low trace.
Okay, and what are some considerations when you want to run the solutions that you've made, because they contain a lot of borate and salts?
Yeah, that's a good question. Usually we do recommend to dilute the solution to at least 250 millimeters, but you could pass them to 100. But you have to get an equipment that can handle a high salt solution. So meaning a nebulizer specialized. You have to think with the torch with an injector that's wider than usual, so it can handle high salts again. And argon humidifier also, not to neglect. But you have to be equipped for these kinds of sample. Once you have them, what you can do, if you have other techniques, other calibration on your ICP, you can have a dedicated torch for your method and change it when you do high salt solutions. But once you handle everything, you shouldn't have problem to analyze that. You might also have to play with the condition, like the RF power and things like that, but it's manageable.
Okay. Well, I see no further questions, so I'll give just a brief moment for any participants, please. We're here now. We're live from Canada with the specialists. So if you have any questions, please put them in the chat box.
So my crucible is all empty. No, nothing sticking in it. And I can go back, fetch my solution in the beaker. So that's it.
Okay. Well, thank you very much.
You're welcome.
Raja. I'm going to take over now with an ending slide.
Sure.
There's a question, Jeroen, from Davy.
Oh, yes. Just a question came in, Nadja, if you could, could help us with this. Do you have experience with making beads of samples with metals, for example, copper?
Mm-hmm. He wants tricks to proceed copper.
I think that it means that there are copper flakes maybe in there. So I think we first have to oxidize it then.
Yeah, if it's unoxidized, you have to take the good oxidation. Sometimes it's heating. Sometimes heating works. I'm talking of preheating, no flux, like in a muffle furnace or something like that, or directly in the Catanax. You can go. We have liquid oxidation with strong acids, or solid oxidizers. So the solid oxidizers have to be chosen accordingly to the type of metals, because some don't work with pretty specific metals. Yeah, but it's possible.
Okay. Then there's another question that came in. In catalysts application, could it be possible to use fused beads, an example, when 1 to 3% palladium on ALOX and still have proper beads?
We do had some cases soon, not too long ago, with like 5% of PGMs like palladium and platinum and things like that. So it is possible, but we have our dedicated tricks to do that. But if you wanna have take a look or something, you can always reach out, and it will be our pleasure to show you what we have in hand.
Okay. Well, this brings me to the final slide. Ties, you can contact us to have further information about this application. We can always test samples when people are interested to see if this can work for their sample. We can provide method development for specific applications. We will Catanax will make a very good report of your specific sample. And of course, this was a general webinar, but we can also do application specific webinars. After me, Aileen will do the closing of the webinar. And for now, I would like to thank you on behalf of Specs Europe, Specs Catanax Europe, and Instrument Solutions for attending this webinar. And in any case, if you need any further information, please contact me.
Well, thank you very much for the presentation and the demonstration. Very nice to see a live demo all the way from Canada. All the webinars in this online week have been recorded and are available to watch as a replay. So to all the viewers, you'll receive an email with a link to view these again, or maybe forward it to a colleague if you like. We are very curious also to hear how you've experienced this week. So in the email, we will include a link to a short questionnaire, and we would really appreciate it if you could fill this one out. And if you'd like to follow more webinars, please keep an eye on our website, where we will share all the activities for 2021 very soon. Then thanks again, Jeroen and Nadia, and we hope to see you all again at the next online week. Thank you. Bye-bye.
Bye-bye.
Bye.